Hello everyone. I'm here to give you a brief lecture on the modes of color appearance. So let's get started here. All right, let's get this full screen. All right, so the modes of color appearance. So we were talking about Albers in the week past and thinking about the way color can deceive us and how color is relational and how Albers says that color is the most relative medium in art. Well, a lot of this has to do with our ability to perceive, how our eyes work and how our environments work. So the modes of color appearance are more situational. So it's not about having a consistent light source and playing with varying colors. It's more about how color exists in the world and how the different manifestations or possibilities of the way we perceive a particular color are relative, in particular to their environment. So let's talk about some different environments in which we perceive color and how those environments and conditions change or affect our perception of a particular color. So David Katz is a philosopher, color theorist who wrote this book called The World of Color. So he had a section, or part of his writing, introduced some of these concepts to us as a color theorists ourselves. So the modes of color appearance, here are some of the major ones we're going to cover. Illuminant, which is a source of light. Illumination, light that fills a space. Surface color, color that appears on or in the surface of the object. Film color appears as a thin transparent layer between the eye and an object, which is independent of the object's surface color. Transparency, which is transparent color made by the surface color plus color of a transparent object. Volume color, transparent color that fills a three-dimensional space, color of transparent fluids, for example. Reflection, reflections in a shiny surface, reflective color appears behind the reflecting surface. So I'm going to go over each of these in detail, so if some of them seem a little unclear, please, I'll get there. So, illuminant. You guys will need to know how to define each of these, and we're going to be using them in our assignment for today. So please be aware of how you can perceive of and comprehend these and even recreate them yourself. So this one's pretty simple. Illuminant is a source of light, an illuminating device or substance. So here are a bunch of examples. I'm sure these will not come as surprises to you. They're very everyday. A flashlight, headlights, lamplight, street light. These are all examples of artificial light. Celestial light, in this case moonlight, starlight, the aurora borealis, or sunlight. So the sun in and of itself is an illuminant, but typically we understand illuminance in a condition in which the light isn't completely full. If we are viewing a well-lit day, the sun is the illuminant, but you'll see we might talk about it more in regards of illumination, which is our next one. But otherwise, when you're wanting to display clearly, at least clearly display an illuminant, oftentimes you need a somewhat unlit environment in which to highlight the lit item. So for our cases, just remember, the less light in the environment, the more dramatic the illuminant, right? So in this moonlight example, because it is so dark out, that moon is really intense and the light from the moon is really dramatic. The lamp light is quite a bit of light emitting, but if that lamp is in a really bright room, that particular illuminant is not going to be as poignant or intense. So the illuminant is more dramatic when the lighting conditions are dimmer, allowing that illuminant to be really prevalent. Oh, and I shouldn't forget firelight. Another naturally occurring but not celestial light form. Fires, lanterns, candle lanterns, things like that, candles. So when we have full light, we'll call it illumination, light that fills a space. These are pretty basic terms, but a lot of this the reason we talk about these in classes is that you need to understand the difference in our visual perception and how you might describe this or replicate it in your creative life. So illumination is light that fills a space, a lot of different illuminants, for example, or full daylight, like in this case, very bright sun allows for a full illumination, a very well lit room. So multiple illuminants, like I'm not thinking about this as an individual illuminant. There's a lot of illumination, lots of light. A very bright, beautifully lit, gorgeous architectural space, full light. Oh, a slightly pixelated gallery installation shot. This is a combination of artificial and natural light from the skylights. An interior office space. I like to throw in a few different examples. Another artificial natural combination, a fully illuminated room. Surface color. So we'll use these different terms because we'll occasionally need to define how we're talking about color or where the color is coming from. So surface color is the color of an object, for lack of a clearer term. So the color that appears on or in the surface of the object. Sometimes insides are different colors, right? But so this is just like the term we would use to label whatever it appears to look like. But as we will find out, / you will be learning, the surface color can be manipulated by the environment. So in a dark room, an orange, we know it has a surface color that's orange, but it might appear differently to us. So I just pulled this image. I was looking for examples of surface color, and there's this thing called the scribble pen. I don't know if anyone's ever used it, but it can supposedly read 16 million different colors and then create an identical match. It's like using a Photoshop eyedrop tool to pull the color out, but you can do it and then immediately draw, which seems very cool. So for a very super easy, simple visualization, all the objects on the left are surface color red. In the middle, surface color blue. On the right, surface color yellow. And as you could probably guess by now, or hopefully you can at least come to this quickly, these are our primary colors. Very simple. This is like the kind of color you learn when you're a child. This is the name, this is the object, the name of labeling an object with a color. So it gets a little complicated when we integrate something like film color. So the way we define film color appears as a thin transparent layer between the eye and the object, and it's independent of the object's surface color. So in this case, these mountains that are receding into the distance, they are not purple or pink in every lighting condition. In a typical lighting condition, I might guess that they're more like a dark green or maybe even a grayish green, probably some brown in there. There looks like there's some trees. So my brain knows that in a full illumination, that it's probably more like a brown or a gray. But in this moment, the film color, which is atmospheric perspective, is creating the appearance that these mountains are purple. These purple majestic mountains. So they're both at the same time. Like they can have a surface color that is true in one lighting condition, but in this lighting condition, these mountains are purple. We can definitively say that, even though our brains understand that the surface color might be something different. But the atmosphere and the way the light is hitting the atmosphere, the angle of the sun, creating a sunset effect, creates a film color. It's an imaginary, transparent layer, usually doesn't exist. In this case, it's microscopic, molecules in the atmosphere, water droplets. So this is from an article that really dissects, I have it down there if you guys want to read it, from an academic journal where these scientists break down our perception and talk about film color, because I think this is one of the hardest ones for students to get. So the sky in figure 7 is the photograph in the middle, is not perceived to be the source of light, nor is it perceived to be any kind of surface. And although we can appreciate that we are looking through air, we do not perceive the air as having any color of its own. We do not think that we are looking through a volume of blueness. The blue of the sky is not perceived in the illuminant, surface, or volume modes. So we're going to get into volume in a second. It is an example of film color. This is color in its purest form, not part of anything, just color. Furthermore, the other modes can all be reduced to film mode. So a film can obliterate whatever sort of color perception is occurring separate from it. Just like the mountain example I gave. The mountains have a distinct surface color, but the film color is dominating and is altering your perception. And so you perceive it as a different color. So, like I said, furthermore, all other modes can all be reduced to film mode if you look at things through a small aperture that has the effect of removing the content. This can be simulated by selecting a small area from a photograph and representing it in isolation. So you can see on the right, they took the photograph, so the light is still and captured. And essentially using like an eyedrop tool in Photoshop, you can pull and isolate the actual color. This is like Albert's factual versus actual color. Factual is like the color we know that it is in controlled reality, like full illumination. But the actual color is what we're seeing, what is our reality in this moment. But so if you pull a dropper sort of version, and you're plucking the color out from this moment in this reality that you're seeing in this photograph, the creators here selected and pulled these different areas: the film of the sky, the illuminant of the streetlight, the surface of a wall, and the illumination on a wall. So the illuminant casting light and creating illumination on a wall. So, like they said, this can be simulated by selecting a small area from a photograph and presenting it in isolation. The color squares besides the photographs in figures 7 and 8 are pulled from the photograph. So, there are several other examples of film color. A cast shadow, for example. So if you see on this top left example, you have a mountain or a hill, I guess, depending on what you want to call it. And so you see that in a majority in full illumination where the sun is bright, the color of the grass is this bright green. When the shadow comes over top, the color of the grass changes. We know the surface color is the same, but the film of the shadow alters the color of the hill. Smoke in the city obscures to some degree and creates a film in the sky, which we know that whole city isn't light gray, but it is in this image, and it would be in the way you would perceive it if you were witnessing this in real life. Steam in a street on the bottom left, having air and water molecules floating through. Also, it's going to be refracting light around it, but it's going to create a bit of a film in the air that's going to alter our ability to perceive whatever is behind it. Another example of cast shadow there in the middle, which the refracted blue light from the sky is changing the shadow to actually look a little bit like blue-gray. And on the bottom right, the idea of like a dust storm. So that's a little bit more physical and tangible maybe, but relatively microscopic dust particles, but at a quantity that's dense enough that it can really alter our perception, creates a film layer of dirt over the sky in this case, or some of the trees. So the tree, our ability to perceive that tree, for example, just above where those cows are, is altered, and the color of the tree looks different. It looks like more of a greenish tan because of the film layer of the tan brown dust in the air. So we can talk about film layer more if you guys still have questions. I know sometimes students, they linger on this and they get a little bit confused, because honestly, film layer is everywhere all the time. And I think it's very easy to feel like it's obvious and it's like overly simple, but this gets really complicated, like if you become an illustrator or an animator, or if you have to actually create the illusion of something. obstructing or blurring or, these different examples I'm giving of film color, you actually have to put down a different color to show that there's some effect of a film layer. So this is just a word to talk about the difference between a surface color and a film color. Transparency, which we've already talked about, is basically a surface color and then a transparent color on top. Different layers of transparencies can also create this effect, but usually they have to be on some semi-opaque surface for the effect to be obvious. We've been talking about this a lot, and you guys are already deep in transparency discussions with our layered transparency projects that we're working on right now. But so various opacities of transparency on that right example. So volume color, a transparent color that fills a three-dimensional space. So film color is typically also in a hypothetical three-dimensional space, but volume color actually has mass to some degree. Usually it's liquid, but that's just an easy generalization. That's how I think of it, at least. So in this case, the water has a slight blue hue, predominantly from refracted blue light from the sky, but the entirety of the liquid, which has mass and fills a space with volume. This is going back to your physics class. Hopefully you guys have a little physics memory. So the color is altering everything you see on her. There's a film color from the volume color. They're kind of similar. But so this is specifically related to volume. Volume color is a slight blue. So her skin is not quite that pale. It looks a little bit brighter and warmer in a full illumination. But in this scenario, all of the color has a slight layer over it, which is a volume color. Here's a slightly blurry image of a volume color like champagne, which has a slight, sort of soft golden color to it, where the silver on the, this is a little tricky because the surface of the ring is actually reflective, which is its own sort of property, but the volume color is affecting our perception of the ring in its entirety and altering our color perception of that object because it is submerged in a colored liquid. All right, here's something I made just for you guys. This is a cup of tea in my studio from a while back and 3 different color silicone straws. And so I actually did the same experiment that was used in the example from the study that I showed you. So I did this in Photoshop. So you can see you see the little circles. There's a little code at the bottom, but there's little circles where it shows you where I pulled the color in Photoshop. But to show you the example of like the surface color of the straw when it is not affected, the transparent glass is clear and has little effect on the appearance of the color of the straws. So I pulled the surface color of straw 1, 2, and 3, and then I show you the film color of the straw, colored straw number 1, film color of colored straw number 2. So these are all related to, so when you're thinking about the difference between volume color and film color, the liquid, which is occupying a voluminous space, is a volume color. And in this case, it's T. But the way we talk about it is there is a film layer from the volume color that is affecting our perception of the surface color of straw number 1 and creating a film color for straw number 1, which is right below it on the top there. So as you go down, you'll see the purple straw. When it has nothing covering it and it's in full light at the top, it's this bright purple. When the film happens over the surface, that is due to the volume color. It changes to like this more maroon, and so on. So you can see all the way down. So the ice cubes as well, that ice cube color, which is independent from the volume color. And then there's a film that comes over the surface from the volume and alters the color or the perceived color of the ice. So we understand that the ice is an off-white, white color in normal circumstances, but the color we perceive when it is being affected by the volume color is a film color. Boom, there's a bunch of concepts for you to just let sink in. So when this becomes really important is when you are replicating these concepts. And you have to think about what you're actually seeing, because sometimes the color you see is isolated and you don't always have context for what that object might look like in full illumination separate from volume color, for example. So it's worth having the terminology so that you can distinguish which colors are affecting which others based on their conditions, like the volume or film. And note that each of these are different colors. That's the whole point, right? So using the terminology to then understand how to properly define why the first green is different from the second green, and it's because there's a film color, and that is related to the volume color. There we go. So, I'm sorry, guys. So, see, I still make mistakes. I gotta move my little box of my face around. Okay, so sorry, guys. I have to move this. My mouse is not showing up for me, and I have to move this image box so that I can read the text over here. But it's not working. So the question basically asks, what's the color of the water in the Grand Canal of the lagoon in Venice? So the same researchers from that previous study that I mentioned broke this down and took different photographs to talk about the differences between surface color, film color, and volume color. So the canals of Venice have variously been described as jade green, lilac, pale blue, brown, smoky pink, lavender, violet, heliotrope, dove gray. After a storm, the color changes as the water becomes aerated. On a hot afternoon, waters may seem orange. The colors of the sky and the colors of the city are refracted in the little ovals of ochre and blue. It is all colors and no color. It reflects and does not own color. It becomes what it beholds. So we can see here from the bottom photographs, and the top ones I guess too, but that our perception and the way we perceive, I guess, the color of this canal changes based on the conditions of the lighting and actually the volume color as well. So on the first example on the left, because the water is more placid and still, it's considered reflective. So in this case, it's actually, bouncing light back and reflecting the color of the sky. In the second example, it's partially reflective with some volume color. So the sort of muddyish water, muddy is probably not the right word, but sort of like murkyish, greenish water that it typically exists as like a volume color, is intermingling with some reflective qualities and creating this perception of like this brownish blend of this green and orange. So if we were to go in there and break it down pixel by pixel, you'd see each colors individually, but as a whole, when you kind of read it from a distance, they blend into one sort of brownish tan color. And then the third example is a solid volume color. So it's not reflective. You're seeing into the water. It's not very transparent or translucent. It's relatively opaque. And the solid volume color is more of a murky green. So water is very elusive and can change and deceive us in different ways based on how reflective or the sky conditions, all of the above. So as I've hinted at, reflection is on a shiny surface. Reflective color appears behind the reflecting surface. So this is a installation artist who's typically based in New York, who does these really beautiful, her name is Sharon Loudon, it's kind of on the bottom there, bottom left. But she does these huge rolls of reflective paper, or not really paper, but material, and then she folds them through the space and it bounces light. I'm sure you guys have seen reflective surfaces, they're everywhere. So this is from that same study I mentioned, and there are two groups of cylinders from figure 20 showing scales of increasing gloss. So reflective surface, gloss is another word for something being reflective. and metallic luster. So that's just a different type of a reflective surface. Like a luster has a different sheen. The scales have matte white as a common starting point, and then they just vary the intensity. So you can see there's light being bounced off. Matte is going to be capturing more light and not reflecting as much light. So there's two different versions of a gloss and a metallic luster from left to right. An artist who deals with reflective surfaces consistently is Anish Kapoor. So, and Jeff Koons, I should say, there's multiple. So the top two, maybe some of you have been to Chicago or lived there. And the Bean, as it's called, in Millennial Park is one of Anish Kapoor's most famous works, but he has done several reflective pieces. And then on the bottom left, Jeff Koons, who is very well known for his large and small balloon animals. So this study that I mentioned from before has some really great examples of mode, like models of appearances, and talking about different reflective relationships. And this is just a very systematic chart that talks about white light moving through these different modes of appearance. So like soft diffuse light versus hard and focused light on what is a transparent or translucent white on the left, but semi-opaque versus a transparent clear on the right. And then talking about transparency to cloudy, full opacity, like opaque white, matte white on the bottom left, middle left, or I should say middle left, and then bottom, the middle right, mirror reflective. So anyways, this chart's kind of dense, but it just talks about different reflective surfaces in relationship to different light, and then absorbent black in the middle, sort of like the least impacted by a white light. And then they give examples of light quality, something being like a hard light or a soft light, more diffuse light versus more direct light, and then its appearance in nature, and then onto different objects and surfaces. I'm not going to have you guys get into this at great detail, but it is something that, especially if you use, all of you going into some sort of representative field where you're going to be wanting to replicate our visual perception, whether that be in illustration, animation, even in painting and drawing, or other maybe sculptural modes, it's good for you to understand how these phenomena work so that you can learn how to replicate them in creating believable illustrations, for example. So all these different conditions of objects and how they're affected by light. So translucent colors, opaque matte colors, glossy colors. So thinking about how surface is affected by light and, you know, alters our ability to perceive an object. Metallic, textured, all these different conditions. If anybody's really excited about this, please let me know. I have a PDF of this entire study. I just kind of pulled the most interesting images and highlight them. So I'm sure you guys are going over some of this in your drawing class, but since we're talking about it in relationship to color, I just want to bring it up a little bit. So the idea of reflected light and light casting back onto the object. So cast shadow is the object receiving the light bouncing back up, and then oftentimes there's a color of the surface color of whatever the light is hitting. It will bounce back up onto an object and oftentimes create another additional color. So for this middle red ping pong ball example, the cast shadow, which is kind of in the middle center right above on the object, we know the surface color of this ball is white, but once you get into the shadow, obviously the color changes. It turns it's like yellow gray, but the area where the cast shadow of the reflected light is bouncing back up, there's a little bit of like a pinkish gray happening right in that moment there. So anyways, there's a lot of subtle things that happen with light in relationship to objects, in particular based on their surface quality. So I just want you guys to be made aware of this, and we're going to be doing some drawing and observational studies in relationship to this for our in-class / homework assignment. So on the right here, just a refresher about observational light and highlight, halftone, shadow as light evolves and change over a surface of an object, cast shadow, reflected light. So the cast shadow onto the surface creates a film color that changes the perceived color of whatever that surface is. So many interesting ways to talk about color. So here's just some nice visuals for you all to consider. As just a refresher, the terms that we're going to be honing in on for our understanding of these concepts for class this week: illumination, or excuse me, illuminant, a source of light; illumination, light that fills a space; surface color, color that appears on or in the surface of an object; film color, appears as a thin transparent layer between the eye and the object, independent of the object's surface color, but alters the perception of that object; transparency, transparent color is created by a surface color and a color of a transparent object; volume color, transparent color that fills the three-dimensional space, color of transparent fluid; reflection, reflections on a shiny surface or in a shiny surface; reflective color appears behind the reflecting surface. So there's an illusion that the color is within, even though it sits on the surface. Like a mirror. You like look into a mirror and it looks like there's a version of you within the mirror, even though it's obviously bouncing right back off the surface. So now that we have gone through all of that, please go back and revisit any of the sections that are unclear to you. We will be talking about these in class and building our homework assignment around it, which are going to be doing 3 still lifes with specific color conditions and lighting conditions for you guys to explore and understand the way color is affected by different conditions. So please take note of everything I just talked about. Please go back and revisit the lecture if that's helpful for you. And please write down any questions you have so that we can address it in office hours or in our small group meetings so that we can talk about and clarify anything that you guys need, questions you might have. So thanks for watching, and I will see you guys very soon.